My name is Mitch. Today, we will learn about electricity. We use electricity constantly in our daily lives. It is one of our most important types of energy and power that we use. Electricity operates our lights, runs our refrigerators, kitchen appliances, and powers motors. So electricity is very much important to all of us. So electricity is a type of energy that can build up in one place or flow from one place to another place. So there are two types of electricity, static and current. So static electricity, when electricity gathers in one place, so it is called static electricity. For example, a charge comb picking up small pieces of paper due to static electricity. Lightning also a powerful example of static electricity. Current electricity. So it is an electricity that moves from one place to another place. It is known as current electricity. Examples of current electricity are starting a motorbike, turning on a light, watching TV, playing video games, charging a cell phone, and many more. Electricity, it is a property of matter that results from the presence or movement of electric charge. According to modern theory, matter is electrical in nature. So there are structure of matter. So first, let's define what is matter. Matter, it is anything that occupies space and has mass. Atom. It is the smallest particle of an element that is capable of independent existence. Molecule. It is the smallest particle of matter, an element or a compound that is capable of free existence. Element. It is a substance that cannot be decomposed any further by chemical action. Compound. It is a combination of two or more elements. And mixture, it is a material composed of two or more substances, a combination of element and a compound, each of which retains its own characteristic properties. So there are basic data about the atom. First, proton, it is a positively charged particle, while electron, it is a negatively charged particle. Neutron, it is a particle with neutral charge, no charge. Atomic number, it represents the number of protons or electrons of an atom. And atomic mass, it represents the sum of protons and electrons of an atom. So ion, it is an atom or a group of atoms that has a net positive or negative charge resulting from an equal number of positively charged protons and negatively charged electrons. So it is an energy level or region about the nucleus of an atom in which electrons move is called shell. So the atom has 5 shells, namely the K shell, first orbit, the L shell, second orbit, the M shell, third orbit, and the N shell, fourth orbit, and the O shell, fifth orbit. Valence electron is the electrons found in the outermost shell, or valence shell, or orbit of an atom. So basic data about the atom. Proton has a charge of 1.602 times 10 to the power of negative 21 positive and a mass of 1.672 times 10 to the power of negative 27 kilogram, while electron has 1.602 times 10 to the power of negative 21 negative and a mass of 9.107 times 10 to the power of negative 31 kilogram. And neutron has no charge. It is neutral and has a mass of 1.672 times 10 to the power of negative 27 kilogram. Here we are going to study the electrical classification of materials. And you can also say the difference between conductor, insulator, and semiconductor. Then let's start this topic. First, The electrical conductors. These materials that allow the essentially free passage of current when connected to a battery or other source of electrical energy. Electrical insulators. These are materials that possess low conductivity or offer a relatively high resistance to the flow of electric current. They are also called as dielectrics. Electric semiconductors. These are materials that have conductivity about midway between good conductors and good insulators. We studied the properties of charges when it is at rest. In reality, the charges are always moving within the materials. For example, the electrons in a copper wire are never at rest and are continuously in random motion. So therefore, it is important to analyze the behavior of charges when it is at motion. The motion of charges is called electric current. Electrical current. It is the motion or transfer of charges from one region of a conductor to another. Its unit is the ampere, named after Andre Marie Ampere. So there are sources of electric current. The following are the methods by which electric current can be produced. First, static electricity from friction. Second, thermoelectricity is electricity from heat. Third, piezoelectricity is electricity from pressure. Fourth, electrochemistry is electricity from a chemical action. Fifth, photoelectricity is electricity from light. And lastly, magnetoelectricity is electricity from magnetism. So there are fundamental units of electricity. Electric voltage, V or E. It is the driving force behind current flow. The unit of voltage is the volt. Voltage level governs the amount of current flow. An increase in voltage causes more current flow and vice versa. Next is the electric current, or I. It is the motion or transfer of charges from one region of a conductor to another. Its unit is the ampere. Electric potential difference. It is the difference between the electrical potential of two charged bodies. Its unit is the volt. Next, electric resistance. It is the property of a material that limits the amount of flow of current and converts electric energy to heat energy. Its unit is the ohm. What is Ohm's law? Ohm's law is a relationship between voltage, current, and resistance. How they relate to each other. Ohm's law was developed by German physicist George Simon Ohm, who undertook many experiments to develop his theory, including measuring current by touching electrical circuit and how much it hurt. According to Ohm's law, at steady-state condition, the voltage across a resistor is directly proportional to the current flowing through it with the temperature remaining constant. There are three formulas used for Ohm's law. The three formulas we use for Ohm's law are voltage is equal to current times resistance. Resistance is equal to voltage over current. And current is equal to voltage over resistance, where V is the applied voltage in volts, I is the current drawn in amperes, and R is the resistance in ohms. There are conditions for Ohm's law. First, Ohm's law can be applied either to the entire circuit or a part of a circuit. Second condition, when Ohm's law is applied to a part circuit, part resistance and the potential difference across that part resistance should be used. And third condition, Ohm's law can be applied to both DC and AC circuits. There are limitations of Ohm's law. Ohm's law is not applicable to the following: for metals which get heated up due to the flow of current through them, for electrolytes where enormous gases are produced on either electrode, for vacuum radio valves, for arc lamps, for semiconductors, for gas-filled tubes in which the ions are generated as a result of current flow, for appliances such as metal rectifier and crystal detectors, in which the operation depends on the direction of the current. The next topic will be the electrical power, electrical energy, and electrical circuit. Electrical power. It is defined as the rate at which electrical energy is expended or used up. It is the rate where electric energy is converted into another form, such as light, heat, or mechanical energy, or converted from another form into electrical energy. Its unit is the watt. So the formula we use for electrical power is P is equal to V times I, P is equal to V squared over R, and P is equal to I squared times R, where P is the electrical power in watt, V is the voltage in volt, I is the current in amperes, and R is the resistance in ohm. Energy. It is the capacity to do work. It is measured in joules. Electrical energy consumption. It is the rate at which power is consumed over a specified period of time. The formula we use for energy is W is equal to P times T, where P is the electrical power in watt, T is the time, W is the electrical energy consumed. Electric circuit. It is a collection of electrical elements interconnected in some specific way through which electric current flows or it is intended to flow. A circuit consists of a source, conducting parts, and a load. Now, let's discuss the closed, open, and short circuit and how they differ from each other. Closed circuit. It is an uninterrupted path that allows a continuous flow of current through an electrical circuit. In a building, the circuit is closed when a switch is turned on. Open circuit. If the path of current flow is interrupted, such as if the switch in a circuit is open, an open circuit results. Short circuit. If an inadvertent shortcut develops in a circuit that permits current flow through an unintentional path, a short circuit is created. A short circuit occurs when current leaks out of the intended conductor path, such as out of a wire with damaged insulation. There are types of circuit connections: series circuit, parallel circuit, and combinational circuit. First, let's talk about series circuit. The circuit elements are said to be connected in series when they all carry the same current. In a series circuit elements are arranged in one single path so that the same current must flow through them all. Properties of a series circuit. The same current flows through all the resistances. There will be voltage drop across each resistance, and the sum of the voltage drops is equal to the applied voltage. Equivalent resistance of a series circuit. As we observe the formula of a series circuit, the formula for solving the total resistance is equal to the summation of each individual resistance, while the formula for solving the total current is just equal to each individual current. The formula for the total voltage is equal to the summation of each individual voltage. I have a sample problem of series circuit. 4 coils having resistances of 3, 5, 10, and 12 ohms are connected in a series across 120 volts. Determine A. Equivalent resistance of the circuit, B. Current flowing through the circuit, and C. Voltage drop across individual coils. So first, let's find the letter A for the equivalent resistance of the circuit. So we can use the formula for finding the total resistance. Total resistance is equal to the summation of each individual resistance. R sub T is equal to the summation of each given resistance, which is 3 plus 5 plus 10 plus 12 is equal to 30 ohms. For letter B, for the current flowing through the circuit, we can use the Ohm's law formula for finding the current. So I is equal to V over R, where I is the current, V is the voltage, and R is the resistance. So total current is equal to the given voltage, which is 120 over 30 ohms nga ato na na-solve sa letter A. So 120 over 30 is equal to 4 amperes. So nakasolve na ta sa current. So now let's proceed to letter C for the voltage drop across individual coils. So we can easily solve this problem since nanatay value sa current. The formula we are going to use is V is equal to I times R. V is equal to 4 times each given resistance. So 4 times 3 is equal to 12 volts, 4 times 5, 20 volts, 4 times 10, 40 volts, and 4 times 12, 48 volts. So that's it for the series circuit sample problem. Let's now proceed to parallel circuit. These circuit elements are connected in parallel when the same voltage is common to all of them. In parallel circuit elements are in different branches of the circuit so that the different currents can flow through each circuit element simultaneously. Properties of a parallel circuit. The voltage across each resistance of the parallel combination is the same. There are as many current paths as the number of branches. The current in each branch is given by Ohm's law, and the total current of the circuit is equal to the sum of branch currents. So, equivalent resistance of a parallel circuit. Here are the formulas we use in parallel circuit. The formula used for solving the total resistance of the parallel circuit is equal to the fraction of 1 over the summation of the reciprocal in every resistance. The formula for solving the total current in parallel circuit is equal to the summation of each individual current, while the formula for solving the total voltage is equal to each individual voltage in a parallel circuit. You can also use the formula for Ohm's law and electrical power in solving for the current, resistance, and voltage. I have here a sample problem of parallel circuit. The equivalent resistance of 4 resistors joined in parallel is 20 ohms. The current flowing through them are 0.6, 0.3, 0.2, and 0.1 ampere. Find the value of each resistor. So before we can find the value of each resistance, we should solve first the total current and the total voltage. The formula we are going to use for finding the total current in a parallel circuit is the total current is equal to the summation of each individual current, which is 0.6 plus 0.3 plus 0.2 plus 0.1 is equal to 1.2 amperes. So now we can solve the voltage using the formula for Ohm's law. V is equal to IR, which is 1.2 times 20, where 20 is the given resistance in the problem, which result 24 volts. So now we can solve the value of each resistance by using the formula R is equal to V over I, where 24 is the voltage. So R is equal to 24 over each of the given current. So that is all for Module 1, Building Electrical System. See you next module. Bye!